Hi and welcome to this lesson where we will be solving exponential equations. What is an exponential equation, you might ask me? Well, it's fairly simple. An exponential equation is a simple equation where my unknown is in the exponent. So for example, 3 to the power of x is equal to 9. Notice how the value that is not known, the unknown, the x value, is in the exponent. And basically what we're saying here is we're asking the question, what exponent must 3 have in order for the result to be 9? Actually, a very easy answer. X must be equal to 2. This method of solving is called inspection. In other words, I'm trying values in the unknown's place to see what will give me an answer of 9. Another example might have been something like, well, let's start with 2. 2 is also easy. 2 to the power of x plus 1 should equal 16. Now we know that 2 to the power of 4 would equal 16. So does that mean x is 4? No, if x is 4, it would be 4 plus 1, 2 to the power of 5, and that's not 16. So we see that x must be equal to 3, because 3 plus 1 is 4, and 2 to the power of 4 is 16. So in this case, x is equal to 3. Okay, this is the method by inspection. That's not what I'm going to be focused on in this lesson. We're going to focus on a method called, or well, at least I call it, same basis. Same basis. It is a very common method, and I do apologize. I do not like teaching methods, but that is simply how we solve simple exponential equations. And it's not really a method, it's just an idea. It's how I can actually solve an exponential equation. And basically what it means and what I need is I do need from the beginning, and that's not number one, that is an actual condition. I need 2 terms. I need an equation with 2 terms. So for example, in both of these would qualify because I've got a term on the left and I've got a term on the right. Okay, the first thing I would do once I have 2 terms is I would get the left hand term equal to the right hand term. That would be the first thing I do, is get my left hand term equal to a right hand term, which in both of these cases is already the case. So the next thing I would do, and I just need to wipe out this, the next thing I would do that would always work is, if it's this case, I mean if it's like this, the next thing I would do is prime the bases. Prime the bases. Okay, doesn't that just sound like delicious recipe? No, what prime the bases mean is, as you can see, I've got a power here on the left hand side, and I've got just a constant in this case on the right hand side. But what I would like to do is prime the bases. I would like to make both sides the bases of those expressions. This is 9 to the power of 1 and this is 16 to the power of 1. I would like to make this base in this power also a prime number. If this one wasn't, I would try and do that as well. And just so you know, it's not always the case. Basically what I'm trying to do is get the same bases on both sides. Now what will happen is, if I have 3 to the power of x is equal to, and 9 can be written as 3 squared. Same on this side, I've got 16 there, so if I say 2 to the power of x plus 1 is equal to 2 to the power of 4, because 16 can be written as 2 to the power of 4, and this is where the magic happens. No, I lie, it's not magic, it is indeed just simple basic logic. If I've got 2 things equal to each other, okay, I used to explain it like this in my classroom, that if I've got one CD player here, okay, or well, CD player works, and I've got another CD player here, okay, and they're both playing the same music. Okay, both of them playing the same music, exact same music. Okay, the CD I put in here, I didn't know what was on that CD. It plays the exact same music as the CD that I put in on this side, and the CD that I put on this side has an actual label. I know what music is playing on this one. Okay, then I know that the music on this CD must be equal, must be the same. In other words, now I can conclude that this CD is equal to that CD. They're the same, it's got the same music on it. Okay, so that's basically the idea. Okay, here's this whole thing here. The power here would represent the CD player with the CD, and the power on this side would be the CD player playing the CD. And I suppose I should use USB flash disk or stuff like that, but it doesn't work so nicely. But nevertheless, basically what that means is that my CDs, here's my CDs, they must be equal. That means X must equal to. Okay, and in this case, it must mean that my exponent on the left is equal to my exponent on the right. Why? Well, because the left-hand side is equal to the right-hand side, okay, and the left-hand base is equal to the right-hand base. That must mean that my left-hand exponent is equal to my right-hand exponent. So it must mean that x plus 1 is equal to 4. Now, if x plus 1 is equal to 4, I can subtract a 1 from both sides to get that means x is equal to 3. Okay? So after I've primed the bases, sometimes I'll have to simplify. Okay? Maybe it is necessary to first get, after I've simplified, okay, to actually get bases the same. Okay, but once the bases are the same, as soon as I've got a left-hand side and a right-hand side, and again, only two terms, that's very important, a left-hand term, a right-hand term, but the two terms are the same, the two powers are the same, the two bases are the same, then I can equate the exponents. And once the exponents are equal to each other, I can simplify. Because now you should have a normal, a simple linear equation. Most of the times it would be a simple linear equation. Let me just show you one more basic example, and then in the next couple of videos we'll look at a few type of examples. Okay, basic example would be something like 16x is equal to 8 to the power of x plus 1. Okay, so what would the value of, no, this is, yeah, this should work. Okay, 16x is equal to the power of x plus 1. Okay, so what we first need to notice is that there's only two terms, a left-hand term and a right-hand term. They're already, let's start it like this: 16x minus 8x plus 1 is equal to 0. Okay, so my first step would be get left-hand term equal to right-hand term, so I add an 8x plus 1 on both sides. 8x plus 1 gets added on both sides, so the left-hand side cancels. Okay, the right-hand side, I got 8x plus 1, there I get left-hand term equal to the right-hand term. Now I prime the bases. Now, so I can say 2 to the power of 4. That is what 16 is, to the x, equal to 8 to the, 8 is 2 to the power of 3. Okay, x plus 1, and then I've got, in my next step I must simplify, and that's important. I use my my exponential laws to simplify. So I got 2 to the power of 4x is equal to, and this, remember, the 3 must multiply both terms there, so it's 2 to the power of 3x plus 3. Great. And now I would have, now I would have my two bases. I get bases the same. In this case, my two bases are already the same, so all I need to do is to equate the exponents. Okay, so I equate the exponents, which is 4x. By the way, equate just means make them equal, so it's not some fancy word really. 2 to the power of 4x must now be equal to 3x plus 3. And now I solve it. Subtract a 3x on both sides. I'm sure you can do this in your sleep by now, so I just get 4x minus 3x is just x is equal to, and on the right hand side, x is equal to 3. And that's it. That's how simple this is. Obviously, we can make this much more complicated. So we'll look at a few more examples in the next video of how we can do these. And then later on, we'll look at actually another method where we will have to factorize. In other words, if I do not just have two terms, if I have more than two terms, I might have to factorize. Well, I'll see you in that video. See you later.